Welcome to third session of this week. We've been talking about the second chapter, which consists of principles of electricity, which we have talked about earlier, and we started off with network theorems. There are three network theorems which you need to know in second year PUC, in first year PUC. So the first one was the superposition theorem. So using superposition theorem, among the three superposition theorem we discussed already. In superposition theorem, what do we do is, if you have to find any branch current, you will have to consider one source at a time if there are many sources. And then eventually you are going to add all the currents due to individual sources. That is how superposition theorem is used. Today we are going to see how Thevenin's theorem can be used. Thevenin's theorem is developed by a French engineer, Thevenin, and it is extensively used by all the engineers for all circuit analysis even today. Okay, so even in second year PUC we are going to talk about Thevenin's theorem, superposition theorem also, and maximum power theorem, power transfer theorem also are extensively used. They are very simple actually. Maybe initially you find it hard to understand, but if you start solving many problems, it will become very easy. Okay, so let us just go ahead and see what is Thevenin's theorem. Now, according to Thevenin's theorem, the statement goes like this. Any two-terminal linear bilateral network having several voltage sources and several resistors, the entire circuit can be replaced by a simple circuit consisting of one voltage source called VThevenin. VTH is VThevenin. It's also called as Thevenin's voltage, in series with one single resistance RThevenin or Thevenin's resistance, where VThevenin is the open circuit voltage between the two terminals and RThevenin is the resistance between the open terminals. So how do we understand this? The circuit, the block diagram and the circuit diagram is here. Imagine you have a complex circuit with many voltage sources and many resistors in this complex circuit. That entire complex circuit can be replaced by a simple circuit consisting of one voltage called as VThevenin and one resistance called as RThevenin connected in series. The output terminals remain the same. You are not changing them. This is what is Thevenin's theorem. So the complex circuit can be replaced by a simple circuit with VThevenin in series with RThevenin. That is Thevenin's theorem. So how to do this, how to get VThevenin from the complex circuit, how to get RThevenin from the complex circuit. Again it is going to be simple. VThevenin, if at all I give you a multimeter. Multimeter is a instrument using which you can measure voltage, current and resistance. So if I give you in the lab, you have this experiment, you will be doing it. To find VThevenin, all you have to do is connect multimeter between these 2 points in voltmeter mode and measure the voltage. That is your VThevenin. For RThevenin, you keep the meter between the two as a ohm meter to measure the resistance, but in the complex circuit you are going to replace all the voltage sources by a short if it is an ideal voltage source, or by its internal resistance if it is a practical voltage source. And if you measure the resistance across these two open terminals, that is your RThevenin. Simple as that. And then you draw circuit diagram like this, VThevenin in series with RThevenin. This will become Thevenin equivalent circuit, and output terminals are as it is. Now all the circuits will have a load also. I told you your the charger is the charger. If the charger is there, the load for the charger is your cell phone, like that. And if there is a battery, load for the battery is a keyboard. You will be putting battery inside the keyboard and the keyboard becomes the load. Like that we will be connecting load also. RL is the load resistance. So if you put RL over here, then you can find current through the load resistance and voltage across the load resistance also. How to do that? When the load resistance RL is here, then these two resistors will be in series. So you need to add them. So to find the current here in this loop, at that time you will have only one loop, then the current IL, load current, is going to be VThevenin divided by RThevenin plus RL. and the voltage drop across RL will be current IL flowing through RL multiplied by RL, that is IL into RL will be load voltage VL. Okay, when we take up the problem you will understand better. So exactly like what I told you in the procedure to find VThevenin and RThevenin is put in the form of steps. You just have to go through all of them. And to find IL, I told you VThevenin divided by RThevenin plus RL, and VL is nothing but IL into RL. Okay, so let us take an example and see how to get the Thevenin equivalent circuit for this particular circuit. This is a kind of circuit you will be given in the final examination also, with the values of course, for 5 marks. So let us just take resistors as R1, R2, R3 and one voltage source V, and we will try to convert this into Thevenin equivalent circuit. So this is our complex circuit which we are going to convert into a simple Thevenin equivalent circuit consisting of VThevenin and RThevenin in series, and output terminals remain as it is. So the first step is to find VThevenin or Thevenin's voltage. What should we do? We have to open circuit this and measure voltage across this. That's all. That is our VThevenin. That is easy if you have multimeter with you. But theoretically what to do? You have to analyze the circuit now. When you open circuit A and B, there is no current flowing here. Open circuit means there is discontinuity, right? There is no current flowing through R3. So it is as good as R3 is not there. This point A is as good as being here, and this point B is as good as being here, or VThevenin is as good as voltage drop across the resistor R2. So all you have to do is find what is current flowing through R2 and multiply by R2. That will give you VThevenin. So how to find current flowing through R2? You have to come back here in this loop. There is only one loop because it is open circuited. Only one loop is there. One voltage source is there. Two resistors are there in series. So if they are in series, what do? We just add them. R1 plus R2. So how to find current in the loop? Current in the loop I is equal to V divided by R1 plus R2. So you got the current I. To find voltage drop across R2, which is nothing but VThevenin, it is I into R2. That's all. So VThevenin is nothing but voltage across R2 equal to I into R2. I is V divided by R1 plus R2 into R2. See? That's all. That is going to be your VThevenin. Now to find RThevenin, again you have to open circuit this and see the resistance from this angle when the voltage source is replaced by its internal resistance, if any. But in our case it is ideal voltage source. For all problems it is going to be ideal voltage source only. So you are going to short it and then find the resistance. Let us take that next. To find Thevenin's resistance or RThevenin, short all the sources and calculate resistance between A and B. If you had multimeter as a ohm meter, then you just would measure. That would have been simple in the lab. But now theoretically you have to analyze how the resistors are connected. So for that, when you have to see the resistance here, you have to assume if the current is flowing in this direction. If at all current is to flow in this direction, it meets a junction, and at the junction current divides. Whenever current divides, that means those two resistors are in parallel. I have told you earlier. So R1 and R2 are in parallel, and if you replace that by one single resistance, that will be in series with R3. So what is the total resistance RThevenin then? RThevenin is equal to R1 in parallel with R2 plus R3. What is a parallel combination of resistance equation? R1 R2 divided by R1 plus R2 plus R3. So that is our RThevenin for this kind of circuit. So you found RThevenin, you found VThevenin, draw the equivalent circuit like this, VThevenin, RThevenin, and replace output terminals as they are, because load resistance is not given, it's open circuit, so leave it as it is. So this is how we get Thevenin equivalent circuit. We will take an example with the values now. Okay, so find Thevenin's equivalent circuit for the given circuit diagram. Voltage source is 5 volts, resistance R1 is 1 kilo ohm, R2 is 1 kilo ohm again, R3 is 0.5 kilo ohms. How to find VThevenin? You have to open circuit output terminals AB and you have to find VThevenin. VThevenin is the same as drop across R2. What is voltage drop across R2? Current I multiplied by R2. What is current I? I is the current flowing in this loop. How to find current flowing in this loop? It is equal to, these two are in series and this is the voltage. According to Ohm's law, voltage divided by resistance gives you current. So 5 divided by R1 plus R2, 5 by 2K is the current, multiplied by R2, that is 1K, will give you VThevenin. See here, V divided by R1 plus R2 into R2. V is 5, R1 plus R2 is 1K plus 1K, R2 is 1K. 1K plus 1K is 2K into 1K. Kilo cancels out. 5 by 2 is 2.5 volts. This is VThevenin. To find RThevenin, again open circuited, and you need to short circuit this and find the resistance. So that is going to be here like this. When you short circuit the 5 volt source, it looks like this, and you have to understand now how the series and parallel combination of resistors are in this circuit. For that, imagine current flowing in this direction. When it flows here, it gets divided. That means these two resistors are in parallel. When these two resistors R1 and R2 are in parallel, you do R1 in parallel with R2, and then this is going to be in series with that. So you have to add plus R3. When two same value resistors are in parallel, we have already discussed it's going to be R by 2. So 1 kilo ohm divided by 2 is going to be 0.5K plus 0.5K equal to 1 kilo ohm. So RThevenin is equal to 1 kilo ohm. We found VThevenin earlier as 2.5 volts. So you just have to draw the Thevenin equivalent circuit like this. VThevenin, RThevenin. So this complicated given circuit with 3 resistors and 1 voltage source can be replaced by 1 voltage source in series with 1 single resistance and keeping the output terminals as it is AB. This is our Thevenin equivalent circuit. Okay, now we will take load resistance also, and then we will try to get VThevenin, RThevenin, and we'll see how to find load current and also load voltage. That is the next problem. Find the current through and voltage across 1 ohm resistor using Thevenin's theorem in the circuit given below. So this is our 1 ohm resistor, so it becomes RL. You can actually find voltage and current across any resistor you want in the circuit. You just have to follow the same procedure. Okay, you can find if you want to find current and resistance voltage across this, then this will become RL. If you want to find across this resistor, then this will become RL. If you want to find across this resistor, then this will become RL, like that. So wherever it is asked question, that will become RL for us, and then we will start following the procedure. Okay, so right now this is our RL, so it is in the right place also. We will start going ahead to find VThevenin and RThevenin. To first find VThevenin, we need to open circuit load resistor. So this will become A, this will become B, and you will draw the circuit again like this with open circuit at the output. So you have to find voltage across AB, open circuited voltage. So like how we discussed earlier, when it is open circuit, current will not flow. This VThevenin is as good as seeing across CD or across the resistor 6 ohms. So you have to find current flowing through 6 ohms multiplied by 6 ohms will give you VThevenin. To find current flowing through 6 ohms, you have to find the loop current here, I. So when you see this loop, since it is open circuited here, this is as good as not present. You just have to look at this loop. You have 1 voltage source and 3 resistors in series. When 3 resistors are in series, what do? You add them. 2 plus 6 plus 2 is 10 ohms. 10 divided by 10 ohms is 1 amp. of current. 1 amp multiplied by 6, that is 6 volts, is equal to VThevenin. So that is what is given here. See, VThevenin is nothing but VAB, which is nothing but VCD, as there is no voltage drop across R4, as current through open circuit is 0. VThevenin is equal to VCD is equal to I into R2. I is V divided by all the 3 resistors in series multiplied by R2. So that is equal to 6 volts. To find RThevenin, what do? We open circuit the output terminals and short circuit the voltage source, because there is no internal resistance. When you short circuit, now you have to analyze how the circuit is. If you see in this branch C back to D here, it is the same current flowing through both the resistors. If the same current is flowing through both the resistors, they are in series. So instead of 2 ohms and 2 ohms, you can replace them by one resistance of value 4 ohms. Okay, that 4 ohms is in parallel with 6. So 4 into 6 by 4 plus 6 is that parallel resistance value, which is 4 into 6 is 24, divided by 4 plus 6 is 10. It's going to be 2.4 ohms, this parallel combination. That is in series with 3. So here when you come back here, that's what is written here. R1 plus R3, these two are in series. So 2 plus 2 is 4. That is in parallel with R2, 6 ohms. 4 is in parallel with 6 plus 3. That is our RThevenin. 4 into 6 by 4 plus 6 gives you 2.4 plus 3. So adding them you will get 5.4 ohms. VThevenin is 6 volts. RThevenin is 5.4. Can we write Thevenin equivalent circuit now? Yes, we can. You can write like this: VThevenin, RThevenin with their values, and replace the output terminals as it is with the load resistance. Now load resistance is given. Now you have to put the load resistance. Up till now you wouldn't consider. You keep it as open circuit. So you write the load resistance now. Now you see the circuit. It's a simple loop. Only one single loop is there. Okay, and the current, same current flows through both the resistors. That means these two are in series. IL is the current flowing through the load resistance, means the same current is flowing. So what is IL going to be? One voltage source divided by 2 resistors in series. So IL is nothing but VThevenin divided by sum of these two, VThevenin by RThevenin plus RL, which is 6 divided by 5.4 plus 1, which is 6.4. It's going to be 0.93 amps. Once you find current in the load resistor, which is IL, the drop across this is going to be IL into RL. That is this. That is VL. So IL into RL is 0.93 multiplied by 1 is nothing but 0.93 volts. So you found load current and load voltage. This kind of problem again will be asked for 5 marks. Okay, so now in addition to IL and VL, they may also ask power dissipated in the load resistor. How do we calculate power? I have told you the equation for power earlier. Power is nothing but voltage into current. So VL into IL will give you power. PL is equal to VL into IL. That also you can do 0.93 whole square it is going to be. That is the power dissipated in the load resistor. Okay, so this is how you solve the problems using Thevenin's theorem. Understand the concept. So any complex circuit can be replaced by a Thevenin equivalent circuit consisting of simple circuit, that is a voltage source called as VThevenin in series with resistance called RThevenin. That is Thevenin equivalent circuit. So this is the assignment for you. On similar lines, same kind of circuit is given for you. You have to find the current through and voltage across the load resistor RL. Procedure is the same. Equations are the same. You write AB here and CD here. Okay, so first to find VThevenin, what should we do? We need to open circuit the load resistor. So open circuited AB you have to write. So VThevenin is going to be same as drop across these 2 points because it is open circuited. You have to find current through 3 ohms multiplied by 3 ohms will give you VThevenin. How to find current through 3 ohms? You have to find current in this loop. You have two resistors in series, one voltage source. 16 divided by 9, 6 plus 3, 9. 16 by 9 will give you the current. That value multiplied by 3 will give you VThevenin. So done. One calculation, VThevenin is over. To find RThevenin, again open circuit this and short circuit this. And you have to see the resistance from this direction. When you see from this direction, you will see that 6 and 3 are going to be in parallel in series with 2. 6 and 3 parallel means 6 into 3 by 6 plus 3 is equal to 2 ohms. 2 plus 2 is 6 ohms. So RThevenin is going to be 6 ohms. Then you are going to write Thevenin equivalent circuit, VThevenin, RThevenin with RL at the output. And then using the formula IL like this, IL is equal to VThevenin by RThevenin plus RL, you find IL, and voltage across RL is IL into RL, find that. This circuit you need to draw in the end. You should not be lazy to draw circuits. I have not been seeing everybody. Some of you are very prompt in writing and showing me the assignment work also. I am really impressed. Everybody has to do. Only when you solve problems on your own, concept will get clear. Otherwise, you will be back to square one when we meet in the college. So from now onwards, I am going to insist that you show me the answer and send it to me. I have already made the group also now. You are going to send it across. Okay, so this is what I want you to do. This sum I want you to solve. Very commonly asked question in the final examination also for 5 marks. Thevenin theorem based question. Okay, so this is how we are going to end the session. Before ending, I'd like to share thought for the day, which I found very interesting. It goes like this: whine less, breathe more, talk less, say more, hate less, love more, and all good things are yours. It's a Swedish proverb. Whine less means stop complaining. Whining means complaining. You should stop complaining. Breathe more means relax. Things are going to be fine. Talk less, say more. Don't be a chatterbox. Say what you mean, or mean what you say. That's what it means. I don't have to tell you the third line. You have to hate less, love more. And when you do all this, all good things are going to be yours. Okay guys, your life is going to be much simpler, happier. Keep this thought in mind, and I'm going to end this session. I'll see you in the next session. Okay, thank you. Have a nice day.